Okay, Precalculus, this is not a new information, new instruction video. This is review. So what we're going to do is I have all the problems done, and I'm going to show you the problem. And if you've got it printed, that'd be more ideal, because then you could do the problem, or you could just do the problem on paper and press pause. I'll tell you when to press pause. Try the problem, and then I'll walk you through the problem. Okay, so these are problems from last class and the previous class. So I've actually done these problems in class before, and in previous videos as well. All right, so example 1 says use the Pythagorean identities to find all the solutions, not on an interval, all the solutions. So we're finding the general form of the equations for the solutions. So we've got cosecant squared equals cotangent plus 1. Now that's not cotangent squared, that's just cotangent plus 1. So I decided to, hold on, use the Pythagorean identity cosecant squared equals 1 plus cotangent squared. Substitute that in for cosecant squared. Well, now I've just got numbers and a cotangent squared. So if I throw all of this to one side, the ones are going to cancel. I'm going to end up with cotangent squared minus cotangent equals 0. Factor out a cotangent. Now I have two separate factors that I can set separately equal to 0 and solve. When I solve this one, I get the cotangent of x equals 0. When I solve this one, I get the cotangent of x equals 1. Where does the cotangent of x equal 0? That's at, the cotangent is cosine over sine, and cotangent is, cosine over sine. So in order to get to the next solution, it's you can just add pi for both of these. So this solution, you can just say pi over 2 plus pi plus pi plus pi plus pi an infinite number of times. So this is pi over 2 plus pi k. This one starts at pi over 4. If I add pi, I end up with the other solution. So seeing as that solution is pi away, I can just write pi over 4 plus pi k, because I'll find my next solution, and then my next solution, and then my next solution, and my next solution. All right, so I'm going to show you this next problem, these next two problems. And again, we're also trying to find all the solutions, and these problems have been set up to use the Pythagorean identities. A lot of times you'll be asked to solve an equation a certain way, but let me tell you, it's just really a hint, okay? It doesn't really matter how you choose to solve. Once you have all these tools in your math box, right? No one's ever going to tell you, solve this problem this way. They're not going to care. It's just like with factoring. You have to factor this way. No, you don't. You can factor however you want, as long as it's right. Nobody's going to care how you do this, okay? This problem says these are set up to use the Pythagorean identities. All right. So pause, do these two problems, and then I'm going to show you the answers. Okay, so the first step is I rearrange the tangent squared equals secant squared minus 1. Again, you're substituting in because 1 plus tangent squared equals secant squared. Okay, so that's about to be factored. And this one I substituted in for sine squared, 1 minus cosine squared. Now be careful when you distribute this negative to this 2, negative 2 times 1, you get negative 2. Negative 2 times negative cosine squared is going to be a positive cosine squared. So, and when you move the one to the other, or sorry, I did multiple steps in one step right here. Once we get here, we realize there's no middle term. On this one, there is a middle term, and that's like factoring a trinomial. This one, I said, okay, there's no middle term. I don't have to factor the trinomial. I can just solve for cosine. So I guess I'll just show everything. Okay, so each of these factors have to be set equal to 0 and solve. This one, you can isolate the cosine and then use the unit circle. Again, here we're using the unit circle, and we're writing all the solutions. Now these solutions for where the cosine is equal to negative 1/2 are not the same distance apart, right? To go from 2 pi over 3 to 4 pi over 3 is a different distance than from 4 pi over 3 all the way back around to the solution here. That's going to be a coterminal angle with 2 pi over 3. So we can't just add the same number. We're going to have to write this as a bunch of solutions plus 2 pi k, and then we're going to have to write this as solutions plus 2 pi k, plus 2 pi k, plus 2 pi k. Okay, and then of course we'll write this one separately, plus 2 pi k, plus 2 pi k. So those are all the solutions. Now this one, however, I don't have to write all 4 of them separately. I can just write 2, because here's pi over 6 and 5 pi over 6 are not the same distance, okay, but pi over 6 and then 7 pi over 6 are exactly pi away from each other, and so is 7 pi over 6 and pi over 6. So those two are pi away from each other, and these two are also pi away from each other. So I'm just going to write those two together as one solution, and these two together as one solution, and then plus pi k. Again, if you got questions in class, we're going to look at these exact same problems in class, I think. Don't hold me to that. Okay, use the double angle formulas to find the solutions on the interval. Now we are finding solutions on the interval. Now the double angle formula I gave you last class was in the notes. It's not here now, but if you haven't done this problem yet, that's fine. Go ahead and substitute in 2 sine cosine for the sine of 2x. Okay, that's coming up. So once you've done that, I'm going to press pause and see if you can do this problem. All right, so now the next step is if I move the cosine over, now I'm going to have 2 sine squared cosine minus cosine of x, okay, equals 0. Well, now if I just factor out a cosine, I'm going to have 2 different factors that I can set equal to 0 separately. Okay, so I can set this one equal to 0, this one equal to 0. And again, I did this problem in class already in the previous video. You just have to be careful. Once you get the general form of the solution, you're not done, because it's asking, it doesn't want the general form of the solution. It wants only the solutions from 0 to 2 pi. So you're going to have to count. You're going to have to start at pi over 4 and add a pi over 2 and list them out until you get to 2 pi and stop. So pi over 4 plus pi over 2, and then 3 pi over 4 plus pi over 2, and you've got to add fractions here, and this is all without a calculator. If you do any of this with a calculator, you're really going to be hating, you're going to be very unhappy next year when you're taking calculus, because there's none of this is using a calculator. All right, let's move on. So we are now going to the next page where I've got some other, yet again, you try problems. Okay, so and these are using the same double angle formula. So go ahead and plug those in. Press pause, see if you can finish these problems out. Go ahead and show you the answers. You can see how you did. Since it's on an interval, make sure you list out all of the answers up to 2 pi and then stop. This one is set up to square both sides, and then also to find solutions on the interval. Okay, so we'll go ahead and we square both sides, and I think I did this problem last class. I did. Okay, and this is just a little, you manipulate it however you can see best. If you've got a sine and a cosine, you might want to square both sides and then substitute in 1 minus cosine squared for sine squared. That's usually what I do when I have that issue or that problem. So once I use the unit circle and I find my solutions, you can go ahead and write them out. Now you've got to check to make sure they actually do work, because you've squared both sides. And when you square both sides of an equation, you end up getting, because if I've got numbers, like -1 doesn't always equal 1, right? But if I go ahead and I square them, well, now I have 1 equals 1. Why isn't my pen working? 1 equals 1. Okay, well, that's true if I square both sides. So you just have to be careful when you do that, because you could lend yourself into solutions that work for the squared equation but won't work for your original equation. So try the next one. Press pause. And I think this is the last problem. So for this one, I went ahead and squared both sides. When you square 2 plus square root of 3 cosine of x. That is something it's got to be FOILed, because you've got a binomial times the same exact binomial. I'm running out of room here. Okay, and you know, it's hard to remember that the cosine of x, that's an angle. And we use x or theta or 2x or whatever is inside that parentheses there. That's an angle. It's a measure of an angle. All right, so that's all got to be FOILed out. When that's FOILed out, you end up with a trinomial and shove everything over to the same side, then factor. This is just algebra. I know it looks different because it's got cosines instead of just x's, but it's exactly the same algebraic steps. So once you factor, the factors end up being exactly the same, so you only have one solution here. So where does the cosine of x equal? Negative root 3 over 2. And then you want to check your solutions because you did square both sides. So you want to check and make sure those solutions actually work. And the way you check it is just like in Algebra 1. You plug them back in and you check. If I do the sine of 7 pi over 6, does that equal 2 plus root 3 times the cosine of, shoot, why did I move this back over here? Come on now. Of 7 pi over 6, right? So I'm going to get negative 1/2 equals 2 plus root 3 times negative root 3 over 2. So I'm going to get negative 1/2 equals 2 minus, wait, yeah, no, that's going to be not a root 3. It's going to be just a 3, right? Root 3 times root 3. So I'm going to end up with a positive 1/2. Negative 1/2 doesn't equal positive 1/2. That's not going to work. So that's why this has been crossed out. All right, I think that is enough review. We will do some more review in class. Shoot, is there one more problem? Oh, there is. Okay, let's just take a look at this last one. All right, so adding fractions. So when you get two fractions that have different denominators, you're going to have to multiply this side by this special one, 1 plus sine of x over 1 plus sine of x. And then this one has to be multiplied by a cosine of x over cosine of x. All right, I have done this problem, so I'm going to move on. And since in the directions it says, it doesn't say what on an interval, then you always, if it doesn't say anything, you just write the general solutions. For it to be in an interval, it's got to say interval. Okay, and the last one I'll just show you really quickly in case you have done it and want to look at your answers. I rewrote the cosecant as 1 over sine. And now, when you take a look at sine of x equals negative 4, I mean, if you just think about the graph of the sine of x, it goes 0 high, and that's at 1, right? 0 low, your low is, it goes from negative 1 to 1. Sine of x is not going to equal negative 4. Okay, so that's no solutions there. But where does the sine of x equal negative 1? Well, it does equal negative 1 at root 3 over 2, and then plus 2 pi. Plus 2 pi, plus 2 pi, plus 2 pi. And the last thing you want to do is, and sometimes people do this first, right when you get to here, is just check if you've got fractions here, make sure the denominator, your solutions aren't including making your denominator 0. Because if you get a solution that makes your denominator 0, that's going to be, it's not going to work, right? It's going to be extraneous. So that, I think, is now it. I think. Yes. All right, that's all. Peace out.